So let's take a look at something that might seem really silly at first. Let's see if you guys know how to count. And I laugh when I say that because there's an easier way to count when you're talking about different ways that you can do something, specifically with probability. This is that fundamental counting principle. So typically, if you guys have learned anything about probability before, you've learned that it's very bad to sit there and just count every possibility. Let's go ahead and see what I mean by looking at A. So in our closet, we have 2 shirts and 3 pants. How many different outfits can we wear? Well, if we've got 2 shirts, I'm going to go ahead and do shirts in white. So I've got 1 shirt and I've got 2 shirts. I also have 3 pairs of pants. So 1, 2, 3. Which means I can have the first shirt and the first pair of pants. Or I could have the first shirt and the second pair of pants. First shirt, third pair of pants. Then I can go through and say, oh, but what if I wear the second shirt? Well, then I can pair it with the first pair of pants, second shirt, second pair of pants, second shirt, third pair of pants. So these are all the different possibilities. So when we count them all up, we'll find out we've got 1, 2, 3, 4, 5, 6 different ways. 6 different outfits that we can wear. Which, again, this is really ineffective. If we look at part B, we can now see that we're including 4 pairs of shoes here. So we'd have to do all this, including a 4th thing with pairs of shoes. So let's take a look at what we actually did here. If we have 2 shirts and 3 pairs of pants, then all we really did is we took those 2 shirts and we gave them each 3 of the different pants that we can wear. So really what we did is we had 2 sets of 3. So if we want to do the same thing for part B, then we need to include those 4 pairs of shoes. 1, 2, 3, 4. So we've got these 6 options, but we've got 4 more sets of them. So if we've got 4 sets of 6, we're really multiplying it again. And that's what multiplication is you're adding up all those different things. Multiplication is glorified addition. And then addition is glorified counting. So really, this is that fundamental counting principle. So if we've got 2 shirts and 3 pants, the easy way to solve it is to do 2 times 3. We have 6 different options. Now for part B, we discovered we had 4 pairs of shoes. Well, we still have that 2 shirts and those 3 pants, but now we've got 4 shoes as well. So 2 times 3 is going to give you 6, and then 6 times 4 is going to give you 24. We now have 24 options because we've got 2 sets of 3 and then 4 sets of all of that. So let's bring out a little bit more of the big guns. Now we've got a 6-sided die, and then we draw a single card from a regular deck. Well, how many different ways can we have that die? We've got 6 different ways. And how many different cards could we draw? 52. So again, I could count through and say, all right, well, I get a 1 on the die, and then I get the 2 of spades. I get a 2 on the die, and I get the 2 of spades. 3 on the die, 2 of spades. 4 on the die, 2 of spades. But that's going to take forever. Really, I've got 52 sets of 52 things that I can put in 6 times. So 6 times 52 is going to give me 312 options. If you want to sit there and count out all those different options, you're more than welcome to. But again, all you're doing is grouping and counting. So this last one, let me go ahead and clear this all off, because this last one's going to take a little bit of space. Let's think about what we've been doing. So I'm going to clear all this off. You guys take a second to read that. We have an electronic lock that can be used to that can be unlocked using 2 single-digit numbers and 1 letter. How many different combinations could you have for the lock? Well, typically when you first read this problem, your first instinct is to say, all right, well, we've got a number, and a letter. But couldn't we also have a letter, a number, and a number? And then couldn't we also have a number, a letter, and a number? So part D actually introduces something very, very interesting. So let's start by just calculating this number, letter. If we've got single digit numbers, then we could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 10 different options. So for this first one, we have 10 different things we can do. Second one, it doesn't say that we can't reuse numbers, so we're more than welcome to still have those 10. Letters, I'm not going to write them out. I hope you guys know your ABCs. There are 26 of them. So if I have a number, and a letter, then I'll have 26 times 10 times 10. Well, remember, for tens, you're just putting zeros on at the end. So I have 2,600 different combinations if all we were allowed was a number, letter. Let's look at letter, number. We've got 26, 10, and 10 pops out 2,600 again. And if you're thinking about it, you probably already know what this is going to turn out to be. 10 different numbers, 26 different letters, 10 different numbers again. Gives us 2,600 possibilities. So now at this point, let's think. We've got 3 different ways we can do this. So now we've got 3 more sets that we could have. And since all of these sets have the same number in them, we could do 3 sets of this 2,600. And that would give us our answer, which is, I'm not going to try, we could do that one in our heads if we wanted to. 26, and then tack on 2 more zeros at the end, times 3 is going to give us 7,800. 7,800 different combinations. Now again, we were able to do that because all of these had the same number to them. But if we had different possibilities for it, we would end up having to add them together, which again would give us that 7,800. Because again, multiplication is just glorified adding, and adding is just glorified counting. So you have to be real careful when you're looking at how you can count things. And again, that sounds really silly. You guys have to be careful about how you count. But it's true. You have to be careful about, do you have to figure out, is the order matter? Because if they specifically told us it had to be 2 numbers and then a letter in that order, then all we would have is 26. Or if it said it had to start or end with a letter, we would have 26,000 plus 26,000. But because they didn't specify what order it has to be in, we could have any one of these 3, giving us a total of 7,800 different combinations you could have.